To create an ionic formula for a bond that involves a polyatomic ion, it's ideal for you to have the polyatomic ion sheet available. Again, you're going to know that you have a polyatomic in your ionic bond if the ending is I-8 or ite. Do remember there are two exceptions to this, well, three on this list. Cyanide is also a polyatomic and it ends in ide. Oxide is a polyatomic, as well as peroxide. But for the most part, these are ending with ite and ate, and that's a major clue to us as we do these types of problems. So in an example of cobalt 2 nitrite, you can see that I have highlighted and underlined the fact that this bond name ends in ite. That tells me use my polyatomic sheet. So I'm going to do the same procedure. I am going to identify my cation and its charge. I'm going to identify my anion and its charge, and then I will crisscross those charges to create my formula. Notice that my polyatomic gets parentheses when I create the formula. Okay, how did I get each of these numbers and how did I ultimately get to this formula? Well, cobalt 2, I know that this is a charge of 2 plus because the Roman numerals 2 in the formula name tell me that the cation in this formula has a charge of 2 plus. Nitrite in the name tells me, look at my polyatomic sheet. I've highlighted for you here that nitrite is NO2, 1 minus. So that's what I'm going to use over here. Now I just need to take my numbers and I'm going to crisscross them. I make sure that the 2 from the cobalt goes outside parentheses because I want to keep this polyatomic all together and indicate the fact that I need 2 of these polyatomics. And then 1 would crisscross over. Let's remember that we don't write 1 in formulas, and that's why you don't see anything here in this formula.